Hi ladies, let's go ahead and get started. I'm going to go over lesson 19 with you. If you would like to get your notebook out right now, you can get your notebook and follow along and take notes. This is lesson 19 called Organic Chemistry. Right, please open your notebook, write lesson 19, organic chemistry. Now, lesson 19 is a special branch of chemistry called organic chemistry, and this branch of chemistry studies all carbon containing compounds. All kinds of compounds that contain carbon. That's what this type of chemistry is about. It's called organic chemistry. If you've purchased organic food before, you know that organic is about natural material. So this is a branch of chemistry that studies carbon. And that's the real big important thing here is carbon. So there's a reason that carbon is chosen for organic chemistry, and that is simply that carbon is a very special compound because it is in group 14 on the periodic table. You can see that right here. You see that? It's in group 14 on the periodic table, which means it has 4 valence electrons. So if I was to draw a carbon atom, it would look like this. Carbon, and it would have 1, 2, 3, 4. 4 valence electrons. And this is really important because it can form 4 strong covalent bonds with other atoms, carbon or any other atom. So I can have a bond here, I can have a bond here, I can have a bond here, I can have a bond here. So the fact that it has 4 valence electrons means that it can form 4 strong covalent bonds. Right now we need to look at some characteristics of these organic compounds. Let's go ahead and start with objective 19.2. Identify the main characteristics of an organic compound. Again, an organic compound is a compound that contains carbon. That's an organic compound. All right, we've got very low melting points. They are non-polar. They are not good conductors of electricity, and they can exist in solid, in liquid, and as in the gas form. An example of an organic compound that's a solid is like the asphalt on the road outside. It's called bitumen. You know, where the car drives, the black asphalt, that's called bitumen. That's a carbon containing compound. All right, if you're not sure what bitumen is, it's just the asphalt, the road that you travel on, just like this. That's bitumen. Okay, this is a solid carbon containing compound. A liquid carbon containing compound is the petrol that you put in your car. And a gaseous carbon containing compound is the propane in your kitchen that you use for cooking. You know, the propane gas tanks in the kitchen used for cooking, that's a gaseous carbon containing compound. So they have low melting points and boiling points. They are non-polar, not good conductors of electricity, and can exist in the solid, liquid, and gaseous form. All right, let's keep moving. There's a special kind of organic compounds in organic chemistry that we study, and they are called hydrocarbons. Okay, a hydrocarbon is a type of organic compound that contains only carbon and hydrogen. And if you notice in the name is hydro for hydrogen and carbon, hydrocarbon. Right, and if you see here, you can see some examples of hydrocarbons. The first one is ethane. You can see it's a 2 carbon. This is ethane here. 2 carbons with 6 hydrogens. You can see here ethene, 2 carbons with 4 hydrogens, and you can see here ethine, 2 carbons with 2 hydrogens. These are 3 examples of something that is called a hydrocarbon. Hydrocarbon means that it only contains carbon and hydrogen. Okay, I'll show you another example here of a hydrocarbon. I'm going to draw something in like a ring shape. Okay, and there's some H's coming off here. Right, is this a hydrocarbon? What do you think? Right, you said yes, you're correct. It's a hydrocarbon because it only has carbon and hydrogen. Right, what about something like this? CCOH, H. Right, is this a hydrocarbon? Right, no, it's not a hydrocarbon. It has carbon and hydrogen, but there's also some oxygen here. and that's not going to make it a hydrocarbon, so this would not be a hydrocarbon. So they are organic compounds that contain only hydrogen and carbon. Alright, let's keep moving. Where do these hydrocarbons come from? Actually, hydrocarbons are one of the reasons that your country is doing very well, because hydrocarbons are coming from petroleum. Now, if you are thinking that petroleum, it means petrol, this is not correct. Petroleum is not petrol. Petroleum compounds are actually found deep under the ground, and they are extracted into this dark black sticky substance called crude oil. And this crude oil or petroleum, they are separated by something called fractional distillation. Crude oil is actually the thing that they call petroleum. Now, if you're thinking to yourself that petroleum means petrol, this is not what petroleum is. Petroleum is crude oil. This is what crude oil looks like. You see, it's a dark black sticky substance. And from this substance, they take petrol. From here, they take petrol. They take kerosene. They take diesel. They take gas that we use in the kitchen. All of these things are coming from the crude oil. Now, this happens by a technique called fractional distillation. You can watch the video. I'm going to put the video in D2L for fractional distillation. You can watch that video and see how this happens. Now, just a quick summary though here. The crude oil comes in to the fractionating column. Here's the crude oil. It comes into the fractionating column right here, and it gets heated. And it gets heated so much that the molecules inside of the crude oil, the really long chain molecules, they start to break apart. See, like this? They start to break apart. And the molecules that are really big are going to stay down here at the bottom. See, the really big molecules are going to come off here. And the molecules that are lighter are going to travel up. Okay, they're going to have a boiling point that is a little bit less, and they're going to be collected into these different columns. So the different molecules are going to have different sizes. Some things are going to be really big, some things are going to be really small. Depending on the size of the molecule is going to depend on which fraction it's going to exit at. Do you see that? And the really, really light molecules with the really low boiling point are going to exit at the top of the column. This is things like gas, propane gas. Okay, so all of these things are coming from crude oil, and they're put into this fractionating column, which heats the substances to very high temperature, which causes them to be collected into these different fractions. Right? This really hot at the bottom and really cool at the top. And the difference in boiling points of the different substances is what allows them to separate. Now, if you look at this table down here, you will see that the really small molecules, 1 to 4 carbon, is going to be gas. Okay, this is like the propane in your kitchen I told you. The things that are between 5 to 10 carbon molecules long, these are liquids. This is like our petrol. Things that are 12 to 18 carbon long, these are liquids also, but they are thicker liquids, so they are kerosene and jet fuels for airplanes. And anything that is above 18 carbon, this is going to be really long chains, really thick. It's going to be a solid, and it's going to be used as bitumen. I told you bitumen was the thing that they used to lay the roads. All right, let's keep moving here. All right, use different types of models, ball and stick model, to show the different hydrocarbons. Now, we've got, for example, a hydrocarbon called methane. Okay, methane. Methane has a chemical formula of CH4. This means we have one C attached to 4 H's. So here's one C, and it's going to have 1, 2, 3, 4, like that. Do you see that? This is methane. This is called the structural formula, where you show how everything is connected. Now, sometimes it's fun to do the ball and stick model. If you have a computer program, you can do ball and stick model. And we even have something called the space filling model. So different ways to represent the hydrocarbons. So you could draw it like this. This is called the structural formula. Structural formula, where you actually show the structure. And if you just have like this, a chemical formula, this is called a molecular formula. Molecular formula. And like I said, you can do ball and stick model and space filling model. Okay, let me do another one for you. I'm going to erase this methane here. And let me do another one. So I'm going to... Okay, sorry about that. Let's look at another hydrocarbon. Let's look at C3H8. So this means I have 3 C's and 8 H's. Now the C's are always going to be connected to each other. So it's 1, 2, 3. And around the C's, you're going to have all of the H's. So this carbon, it already has one bond. Do you see this one? This already has one bond. So we said it can have 4 bonds. So this means that it can have 3 more. So here's 1, 2, 3. Okay. Now let's look at the carbon in the middle. This carbon has 1 bond on the right and 1 bond on the left, which means it can have 2 more. So here's 1H, 1H. Do you see that? And this carbon here, the last one, it has 1 bond on the left, so that means it can have 3 more. So 1, 2, 3. Okay, so this is C3H8. This is what we call the structural formula. You draw the structure. So because you know that carbon can have 4 bonds, we were able to draw the structural formula here. All right, let's see if I can make some space. Okay, let me do another one. Let me do C2H4. Okay, now this is connected C, C. Okay, and this is actually a double bonded structure. So this looks like this with a double bond. All right, let's look at this carbon that's here first. Let's start with this carbon. If you notice, it has 1, 2 bonds, which means it can have how many more? It can have 4 total, so it already has 2, so that means it can have 2 more. So here's 1 hydrogen, another hydrogen. All right, that's 4 bonds total. Right, the other carbon, same thing. Let me draw these back properly. This carbon, also same thing. This carbon has 1, 2, here's 3, here's 4. So each carbon can have 4 bonds around it. All right, very nice. Okay, let me do one more. Let me do one more for you with something so you can see a triple bond. C2H2. Here's C, and this time there's 3 bonds in the middle. So this carbon has already 1, 2, 3 bonds. I'm sorry, not 3. It has 3. 1, 2, 3 bonds, which means it can have 1 more. That's 4. And this carbon, already it has 1, 2, 3 bonds, so it can have 1 more. Okay, this is called the structural formula. All right, structures that have the only single bonds, like the methane and the ethane that I showed you, these are called saturated hydrocarbons. Saturated hydrocarbons means they are full of hydrogens, saturated with hydrogens, so they have only single bonds. Unsaturated hydrocarbons are anything that has a double and a triple bond. So this example that I did here, that was an unsaturated hydrocarbon. This example I did here, that was an unsaturated hydrocarbon, and it's simply because it has a double bond or a triple bond. So it becomes unsaturated. Why am I writing that? I meant to write triple bond. All right, now you can go on to D2L and you can also see the video about fractional distillation. And please take notes on the lesson and be ready in the class to move on. Thank you.